Okay, so I just wanted to make sure you knew a couple things about the HR diagram from yesterday. So first of all, you were comparing on this diagram basically a bunch of different stars, and you were comparing their luminosity right here. You were comparing luminosity, which is actually their absolute magnitude. It's actually their brightness. So over here, there are two definitions that you'll definitely need to write down. Absolute magnitude is the actual brightness of the star as compared to the sun. So actually how bright it is. And then its apparent magnitude is how bright it is appearing from Earth. Okay, so what luminosity refers to is its actual brightness. All right. So yesterday you were comparing that to the brightness of a sun, and so you see you have your one right here. And if you look over, I'd like you to go ahead and plot your sun right here. It is a main. The sun is in its main sequence, and again, these are all main sequence stars right here. But it is in its main sequence, so obviously it's as bright as one sun. And then its temperature, the sun's temperature is actually about 5,800 Kelvin, so that would put it about right there. Again, add the sun to your graph. Okay. So a couple other things. Yesterday you should have seen that the temperature is kind of weird. The temperature down here increases to the left. Okay. So your coolest stars are going to be over here, and they're going to be red. And then your hotter stars are going to be over here, and they're going to be blue. Okay, because they're going to be 40,000 Kelvin. Another thing to make sure you know is that the brightest stars are going to be up here at the top of the graph. Okay, 10 to the 6th power. So again, those are your giants, your super giants, and your blue giants. And that's going to be your brightest stars. Your dimmest stars are going to be down here along the bottom. Okay, these white dwarfs and some of these main sequence stars. All right. So this is your HR diagram. And again, you just kind of need to know how it reads. The other thing I wanted to make sure you knew is the other day you took some notes on stars. All right, make sure you know that light year is actually a distance measurement. Okay, it's a distance that light travels in 1 year. So when someone says it's 4.2 light years away, that means the light from that object or that star left Earth or left the star 4.2 years ago. And so we're actually seeing light that left that star a long time ago. Okay, stars produce their energy through, and I forgot my R there, through nuclear fusion. Okay, and that's the in the nucleus, hydrogen atoms fusing together. Okay, so that's their energy. The two gases that most stars are made of are hydrogen and helium. Okay, mostly hydrogen and then helium. Some other elements that we'll find out about next week are also in stars. Obviously, you should have learned by now, coldest stars are red and the warmest stars are blue. Okay, couple other things. Day before yesterday, you did the life cycle. Okay, you need to make sure that you know, and let's see, you can't see that. Make sure that you know that the life cycle of a star depends on the mass of the star. Okay, so all stars are born over here in this nebula. Okay, so you need to make sure that you know that that nebula, that cloud of dust and gas, is where all stars are born. So from there, they either go this path as a medium mass star or they go this path as a high mass star. Okay, you can see our sun up there. Oops, our sun is a medium mass star. So you can see it is in its main sequence of life. Okay, and it's not going to end up as a black hole. We are obviously, some point, the sun is going to end up as a black dwarf, okay, because it's not a high mass star. Okay, again, two paths of life, medium mass stars end up as black dwarfs, and high mass stars are going to eventually be black hole or neutron stars. So you should have had that from the other day, and that which path they take depends on their mass. All right, so one more page, here we go. Next page, make sure you knew the three types of galaxies, spiral, elliptical, and irregular. You should have drawn those, but what I need you to make sure you know is that a spiral galaxy is what kind we are. The name of our galaxy is a Milky Way. Okay. the oldest stars being in the middle, the newest stars being out here on the edge. What I need you to know is where the sun is. The sun is actually out here on one of these arms of our Milky Way galaxy. Okay, because he's not a new star and he's not an old star. He's a midway point of his life. Okay, so again, older stars, newer stars, and he's out on an arm of that spiral Milky Way galaxy. All right, the elliptical one is going to be more like a oval shape. You should have heard that word before. And then irregular is just like it sounds, very irregular. Okay. Last but not least, make sure you know some of these sun facts. The sun is our only star in the solar system. Okay. I think this one's kind of interesting that it makes up almost 100% of the solar system's mass. Okay. So there's not much left over. All right. So here is the sun's temperature in Celsius, but like we said, when we put it on the HR diagram, it was 5,800 degrees, or 5,800 Kelvin. Sun's generating huge amounts of energy by combining hydrogen nuclei into helium, just like we said. Okay, and this is called that nuclear fusion. All right. One more thing I didn't think I said, but back here, the bigger the star, they burn out faster, okay, because they get so big, they have to burn through that fuel. All right, so you should be ready to go with a star and HR diagram. Oops. I do encourage you to draw your moon phases. Hopefully you can do that. Let's see, I was going to find a blank page. Oh, right here, okay? So I'd like you to see if you can draw your moon phases later. So draw yourself a sun, put yourself an earth, and see if you can memorize the drawing of the phases for your test. Okay, again, remember new moon, full moon, first quarter, third quarter, and then see if you can draw them in so that on your test Monday you can use that. All right, and remember they go counterclockwise.